I'm going to have days here, and I'm going to have viral load here. This is going to be higher, lower. And so what we want to do here is look at the difference between a vaccinated individual and an unvaccinated individual. And by the way, I will share the sources where I got this information from. So I'm going to try to simplify this. So if you're vaccinated, it's going to look more like, by the way, when you have a high viral load, it's not always going to be, it doesn't always mean that you have symptoms. But a lot of times it could be that you do have symptoms. In the vaccinated individuals, you're going to probably have more mild symptoms. And then in the unvaccinated, you're more likely going to have more severe symptoms. So let's just say that's vaccinated. And again, really they were saying it was, from some of the research I had seen, it was saying it lasts around 2 days. So I guess this might be kind of around 2 days. And whereas the unvaccinated basically follows almost a similar line. And then the difference is the viral load is lasting a lot longer. So as the viral load lasts, the more viral load it has, it's not always this way, but more often than not, the more able you're going to be able to transmit it to somebody else. Let's say all right here is where you would be highly transmissible. Everywhere else is not going to be as likely to be transmitted to other people. It's kind of difficult to explain why it's more transmissible. It's not just the viral load. Let me see if I could try to explain this. Hold on. Okay, so this is done. So look at the different variants. So these are very technical pictures. Original variants are going to look something like this. Delta variant is going to look like this. Okay, so if this is one droplet, well, in one of the research studies I saw, 1,240 more viral particles than the original variants. So we have to keep this in mind when we're talking about transmissibility, and also when we're talking about if you are vaccinated or not. And here's why. When you're vaccinated, you have an army, okay? And your army is full and ready to go, okay? So think about these people who are going to take off the Delta variant and or the original variants. It's going to be a lot easier with all this army, okay? So it's never that we were never supposed to get infected. I mean, if the vaccine was never supposed to make you infected, then basically a vaccine would be putting you in a bubble, with nothing able to ever touch you. Okay, that's not how it works. The vaccine recognizes something. You will be infected. So here you have an unvaccinated person. Their army is hardly anything. And the reason why I have one here is this is just to represent your innate immune system, because you have one that you're born with, and then you also have one that you acquire, things that we've gotten over the years as we grow up, right? Now, did you have a previous infection? Maybe you'll have a small army. And this, kind of how vaccines work, really, is that it pretends kind of like you have a previous infection. So it's not to throw out all previous infection. I mean, that if you did get a previous infection, then you will have a small army to fight. Now, do you have as robust army as you do over here? No. It's weird because from what I understand, from what I've read, it says that they don't exactly know why, but for vaccinated individuals, it seems to be getting both the innate and adaptive immunity to be more robust, in response. And whereas in the unvaccinated, it's going to use both, but it's mostly going to use adaptive, which is what we get, right? So for previous infection, you would use your adaptive, right? Adaptive is a slow response, okay? Because they have to think of it as like kind of like reading a book. You have to read a book to decide if that's the enemy or not. Okay. And then once you decide it's the enemy, then you know what to do. Now here, you already read that book. If that makes sense. I don't know if that makes sense. So anyways, you have your innate immunity, which is going to be faster. You have that engaged, and you have your adaptive immunity, which is also engaged, and it's slower response, but it's a lot faster in the vaccinated individuals. Okay. And so what that means is if every little tiny viral particle starts coming, we have a lot of people to cover that. Okay. You know, the longer you stay up here, the longer you have more of a viral load, the more opportunity you're going to have replication of the virus occurring. And that usually also means that you might have more severe disease, but not always. Okay, so you're going to have more severe disease when you have more viral load. Why? Because the virus enters each cell. Let's see. Let me draw this. How am I going to draw this? Pretend this is your cell. Okay. And then you have a virus out here. Coronavirus. Because it looks like a crown. Okay. And these are your spike proteins. Okay. And here you have the receptors. That's, if you guys have seen that, that's called your ACE2 receptors. And so what it's going to do is this is going to bind onto here, basically. And once it binds on, this is the lock and key mechanism that's going to allow this whole thing to come in here. It's like an open door. So now you have the virus in here, and it starts using your cell to make proteins, such as the spike proteins, anything on the capsid. It's going to recreate the RNA that's in the center of the virus. Basically, it's going to rebirth itself using all of your cell's machinery. So the reason why you have more severe disease when you don't have a vaccine is because it's able to get into your cells, okay? Then it starts replicating, okay? It makes more viruses. Then it pushes the virus out. Oops, I guess I should use red. Then it pushes this virus out, and then it goes and attacks more of your cells, okay? And when we say attack, it's really not attacking, it's just surviving. This is how the virus survives, okay? And so when people say, oh, you know, the vaccinated people are the ones who are making this thing keep on going because they can pass it to other people. Well, first of all, the breakthrough is a lot lower on vaccinated individuals than unvaccinated. That's a fact, okay? And then beside that, you are letting this replicate more often in an unvaccinated individual because it has more time to do so because it doesn't have a big enough army to fight it. The more times it replicates, the more times it mutates. The more mutations you have, the greater chance that we're going to have another variant that can elude us, okay? So no, vaccinated individuals are not causing this, okay? Really, what this says is we need more vaccinated individuals. And what it really says, and what all the research says, is we need vaccinated individuals and everybody needs to wear a mask. That's what that says. So because you don't have an army yet, or you have a very small army, you're going to have so many of those viral particles, so many of them with the Delta variant, that it's going to break through, okay? Remember, so many of these are coming in. If you're not vaccinated, it catches more cells. What happens when your cell here is making this? It's not doing its job it's supposed to be doing in your body. This is why people get lung damage. This is why people feel shortness of breath, because your body is so busy making these viral particles that it cannot do what it's supposed to do. This is why you can't smell. This is why you can't taste. There's ACE receptors on these buddies that go next to the neurons in your brain. And when they're on there, it stops you from being able to smell and taste. But why? Because it's doing a job of replicating the virus. It's not doing what it's supposed to be doing. It's making more virus, more virus, more virus. The virus is not necessarily trying to make you die. In fact, that would be a bad idea. That's why Ebola is not really around anymore, because it killed the people too fast. Okay? If the virus can stay there in your body long enough to replicate, mutate, like it's doing now, and causing different variants, then that gives it a better chance at living. Okay? Because the best is going to survive. So the more chances your body has to replicate something, the more chances mutations can happen. The more mutations happen, the more variants can happen. This is what I saw too. This is just one study, and it's a preprint, so you're not going to have full percentages and stuff, but I just wanted to show you, and I linked to this too. You have your unvaccinated with pneumonia and your vaccinated with pneumonia. Okay. Supplemental O2, 21 versus 3. You got 5.4% for ICU, 0% needed for ICU for this study. So here, for how long were they in the ICU? 3 to 9 days. How long? Well, 0. Intubation, 1.5%, and 0. Here, 3 to 11 days of intubation, 0. And well, really, is it really 11 days? Maybe they died on the 11th day. I don't know. Let's see. 30% of them used COVID-19 treatment, and then 7% over here used COVID-19 treatment. How many died? 0 for vaccinated, and 2, I think it was 2 people, which turned out to be about 1.54%. This is just one study, like I said. So you can just look and see vaccinated versus unvaccinated, and a lot of these people who are unvaccinated probably been infected prior. We don't know, but I'm sure some of them have been. So it's not like that natural immunity is any better. And in fact, a lot of it says it's not better. Sometimes in certain diseases, yes, natural immunity is better. But for this circumstance, it's not. It just so happens that we have a more effective vaccine. So that's something to take into consideration. Oh, I wanted to talk about multi-system inflammatory syndrome. So that's happening because for different parts of your body, so I don't know where all of it is, but you're going to have ACE receptors. You'll have some in your brain. You have some in your heart, your lungs, not in sperm, but they do have it in ovaries, but that doesn't mean that you're not going to have kids later, FYI. Let's see. Anyways, you have ACE. We're going to say you have these receptors multiple places in your body. Okay. This is why Miss C and Miss A is a thing, or I don't know if they call it MIS or whatever. I just read it. I don't know. But anyway, sorry if you could hear my kids screaming in the background. But anyway, so the reason why we can have this different things on your body getting infected, different like your systems are getting all affected, is because, well, first of all, the blood's going to run all the way through, okay? And the blood's going to transfer it to different areas where you have different organs. If the organ happens to have one of these receptors, well, guess what? The virus is going to find it, and it's going to attach. It's going to make its way in, just like it did up here, and it's going to replicate, okay? All the virus wants to do is live, and that's its only goal, is just to live. So in order for it to live, it needs a host to replicate itself, okay? And really in here, the capsid's going to open up so the RNA could come out. I didn't really draw that. Well, it doesn't matter. Anyways, however, guess what? If you were to have the vaccine, this capsid would break out here, okay? Because the vaccine is going to pop these keys open. It's a key to pop open this thing. It will open up the capsid. This RNA will be in the blood, let's say, or just anywhere between cells. And if you have a big enough army, it's going to tear each and every one of those viruses up, and it won't be able to enter your cells. Basically, the goal is to destroy all the SARS-CoV-2 so they die. And then so the more that dies, the faster they die, the less replication that occurs means the less likelihood for the virus to mutate. If it mutates less, we'll have less variants. This is proof that no, the people who are vaccinated are not driving this. It's the opposite. Yes, we can still transfer it, but the heightened viral load is for a shorter period of time, and it replicates less in us, so it's less chance for it to mutate, because the replication is the place where it mutates. Okay, so anyway, all right, I hope this made some sort of sense.